The topic of this video is graphing piecewise-defined functions. This is a continuation of the previous video. Alright, so we've already created our graph of h of x. We have that shown here. The only thing left to do now is to determine if it is continuous and find its domain and range. Okay, great. So let's start with, is this continuous? The answer is a big glaring no. This is in three very distinct, disconnected pieces. This very much is not a continuous graph. We cannot draw the whole thing without picking up our pencil. All right, domain and range. So when it comes to domain, the easiest way to determine that is to look at the values of x stated in the if condition. We're going from -4 to -1, not including -1. Then we pick up -1 and go all the way to 4, including 4. Then we go from 4 all the way to 16, including 16. So the smallest number that we have is this value right here, the -4, and the largest number we have is 16, and there are no missing numbers in between. So our domain is -4, 16. And because of this inequality symbol, we have a parenthesis, and because of this inequality symbol, we have a bracket. So there's our domain. All right, range. Range we have to get from the graph. We have to find the smallest, the lowest point and the highest point. So the lowest point, the one closest to the bottom of the frame here, would be this one right there. And that has coordinates 0, 0. Remember, this is range, so we're interested in the y value, so that would be 0. And then the highest point, the one that is closest to the top of the board. Well, it's a tie. We've got this one right here and this one right here that both have a y coordinate of 4. But since we know that the very next thing we're going to do is to try to connect the lowest point to the highest point, it makes sense to choose this one. So 4, 4. So can we trace a path from the lowest point to the highest point without moving along our line or curve without picking up our marker? The answer is yes. And for that reason, we have all of the y values from 0 to 4. There are no gaps along the way. Now, what kind of symbol should we put here and here? Remember that the definition of range is a collection of all of the y coordinates. We have a point on our graph with a y coordinate of 0. Therefore, 0 belongs in the range. Therefore, we need a bracket. We have a point from our graph with a y coordinate of 4. Therefore, the number 4 belongs in the range. Therefore, we need a bracket here. Now, you might be thinking, what about the other parts of the graph? We seem to have completely ignored those. Well, we have, because we know that duplicated values would not be included. For example, let's say we wanted to include some of these points in the range. Well, if you look very carefully, you'll notice that every one of these points has a y coordinate of 3. 3 is already in this collection of numbers. It would be redundant to try to add 3 because it's already there. This collection of numbers goes from a y coordinate of 2 up to a y coordinate of 4, and again, all of those numbers have already been included. They don't need to be included twice. And so for that reason, this is our domain, and this is our range, and that is the end of this problem.